What's good, my analysts, and welcome back. Now, in my last video, I showed some high-level strategies to analyze scheduled task data because it's continually used by the bad guys, and so we should get really good at finding the evil there. Now, I got a lot of good feedback, and people, I really appreciate that, guys. Keep on reaching out. Let me know when you have your ideas. But someone reached out and they said, "Oh, well, Dwyer, that NS, that's all well and good, but you were using enterprise-level tools. What can we do if we don't have access to a Splunk or a QRadar or whatever that might be, or an EDR, and all we have, we're rubbing two sticks together trying to save the world." And so I thought, wow, this would be a great time to show how you can do a lot of the same analysis with just PowerShell, because, like where there's a will, there's a way for PowerShell to save the day. Do I have bars? I should drop a mixtape. Anyway, I'm just kidding. I can feel you guys rolling your eyes. This is great. Anyways, I kind of wanted to show just like using native PowerShell, using Windows Remote Management and PowerShell Remoting, how we can do a lot of this analysis and actually, find some evil along the way without any sort of fancy tools. So I'm gonna share my screen. No slides today, guys. Sorry, so no dog, but we're gonna do this one quick. One take, Johnny. All right, here we go. Share the screen, and here I have a script up here. So the first thing we have to do here is import Active Directory, and we need the module so we can get a list of Active Directory. Now, what I'm going to do for this first example, I'm actually just going to grab the first item, just one computer, just because it takes a while. And the first thing we're going to do is, if you remember what I talked about, it's like, hey, the first thing you should always do if you don't have that data already is you should, do some hash checks, because it's low-hanging fruit, it's easy to do, and we should be doing it as a first level of analysis. So let me just uncomment my little bit of script here, and I'll actually just start it because it does take a minute for it to run. Let me save this off and let it do its thing. So what we have here, the first thing is, notice I have this array here of environmental variables. Now, the gotcha in PowerShell, that if you're not familiar, so especially with scheduled tasks, because a lot of scheduled task data uses the old percent environmental variable percent sort of denotion, and PowerShell doesn't recognize that. It actually switched it over to something that's like a $sign, env, colon, then the environmental variable name. So we got to account for that. So what I do for that is I have this match to say, if your path matches something in here, go ahead and get the full path. And I do that just by echoing it with command, just to get the full path. So converting it from $winder to C:\Windows. And what I'm going to do here is I'm looping through each one of the computers, in this case just one, and I'm going to get a scheduled task. And you can run that remotely using the -sim session. And the data that comes back when you run that command, the scheduled task data actually comes back as an object. And there's a lot of different nested things in there that is really interesting. But the thing that we're most interested right now is just getting the hash for whatever binary is associated with that. And when I'm going to show you how we can do that using the native PowerShell capabilities. So the path to the binary associated with the task is actually nested in a sub-attribute actions execute. I'm just going to save that off to task action just because it's easier to type. Here you can see I'm doing my match to say, hey, if task action matches an environmental variable, let's go ahead and run this command to convert that into the fully qualified path. Next, we're going to enter a PowerShell remoting session, and then we're going to go that, and here is where we're going to use the remote command to say, give me the file hash using the get file hash commandlet in native PowerShell. And you just need, I think this was introduced in PowerShell version 4, it may be 3, I can't remember, but any modern operating Windows system will have it. One of the other gotchas about invoke command when you're doing something through PowerShell remoting is that you just can't pass a local variable in your invoke command script block. You actually have to do it as an argument list. So you have my convert path here. You can see I've passed it as an argument list, and you just got to denote it with a little arg flag there, and then it will send over the argument. So basically saying, hey, remotely run this command locally and give me the results back. And what I'm doing is I'm saving that off into a custom PowerShell object. And you can think of that basically like a CSV, like you would have your column headers, which is computer name and the hash value. And we're going to add that row by row by row. And at the end, we'll just export a CSV, and then you can yeet that up to VirusTotal or Reversing Lives or whatever you have. And oh, it's done. So we can kind of just look. Now, some of the stuff here, you can see like the path there. The binary probably doesn't exist on that system, and that's fine. You could do some testing there to make sure you don't get any red errors. if people don't like them. But it's good to collect that data, even if the binaries aren't there. That could be an indication. You might find like something evil there that wouldn't be there in the past. You want to run that down. Hey, that's interesting. AV might have gobbled it up, but maybe something else happened on there. But you can see we run through that, and I should have a CSV here of hashes, and you can kind of just grab all these and run those against whatever enrichment service you have. So that was analysis number one, no special tools. We're going to run into our next example, which I think is pretty neato, if I must say myself. So let me move this up so everyone can see, clear this out, and we will grab all computers and you guys can just listen to me yammer on a bit. So if you remember what I said in the original video, I was like, okay, so the next thing you want to do is you want to incorporate some sort of frequency analysis. And the first thing you want to do is apply some context to say, okay, I'm going to do frequency analysis on the path to the binary, knowing that I'm looking for evil suspect binaries. I don't really care about the command line arguments, because if it's suspect, I mean, it's not that I don't care, but I'm just looking for suspicious binaries, right? So we're going to do some frequency analysis just on the path, right, to see if anything kind of stands out. Again, same thing. We're going to go out and connect to each machine in the list. Actually, let me just start this because it does take a little bit to loop through this. All of this code is proof of concept. I would not recommend you use this in a production environment at any time, because it's full of inefficiencies. So it collects things repeatedly. You could do some deduplication, and you can speed this thing up a lot of different ways. This is just proof of concept. And what we're going to do is we're going to go through in each one of these. You can see we're going to create a new object. We're going to create a new array, which is basically all the task data. And we're going to loop through and say, give me all of that. Give me the path, give me the arguments. I'm going to show you what we're going to do with the arguments later. And we're going to create this new custom PowerShell object with that data in there. And then, this is awesome, guys. I don't know if you knew this, but you can actually do frequency analysis natively in PowerShell. And we can use that by using the get enumerator function. And what we're going to say is like, give me this object. So this is all the task data. And we're going to group items together by the action or the path. So the path to the binary, and you're going to group all those together, and then we're going to make a count, which is frequency analysis, right? And we're going to sort that in descending order, and then bada bing, bada boom, you look at the results here. Without any Splunk or any kind of fancy tools, we have a stack counted data set of scheduled task binaries, right? And you can see, oh, boom, like Mimikatz right off the top there, right? And you could actually even do some keyword searching on this as well, using like the select string or even match, like I had before, where you could just have a dictionary of all these bad words, and you say, let me just enumerate the all task object, pipe that over to select string, or say, does anything match in my bad words? And if so, write that out. You could do that as well. Here, 4 examples now. You can do keyword searching on that really, really easily. But you can see you can use this one simple command here, as long as I have my object of data to do frequency analysis, and things stand out right at the top. Yep, we got one right up off the top there, Mimikatz. That's probably bad right there. This is also sus, right? If you remember in the previous example, a batch file being called by a scheduled task that's sitting in system apps, that's probably bad. Actually, I know that's bad. All right, so context, right? So we're going to move on. And remember, the next example that I had was the context of saying, well, how do you consider living off the land tools, right? Because the context is different to that. You're going to be more keyed in on the command line parameters of a living off the land tool, right? Because that PowerShell is running, like in and of itself, is not anything to pull on. PowerShell is going to be running all over the time. A run DLL is going to be running all of the time, right? So it's nothing that is going to stand out as a suspect. Clear this out again so we can get a freshy screen. Here, I have another matching object here, and fortunately, the maintainers of the LolBins project, shout out to my boy Chris, who's a big contributor to there, but they do a great job of making this data available through APIs or other functions. And you can just download a list of all of the living off the land tools that they know about. And you say, so I'm going to take a very high level approach to this to say, okay, let me apply the context to say, I care about the command line parameters as respects to a living off the land tool. So we're going to do the same thing again to say, if the path to the to the scheduled task binary matches of living off the land tool. Let's add it to an object and let's do frequency analysis on the command line parameters again. And this is really cool. This will be fast because we already have enumerated that data in our all tasks object. And we can just run this and boom, bada bing, bada boom, frequency analysis on living off the land tools, stacking on command line parameters. Bam, automatically got something good. That one right there, definitely bad. This right here. But if you're not looking for run DLL, calling DLLs with comma start W, so this is the default entry point for Cobalt Strike beacons and the DLLs. So right off the bat, we got evil. No fancy tools required. Easy peasy, lemon squeezy. I will put all this stuff up in GitHub again, just, use it with caution, expand on it, make it better along those lines. If you have any more ideas of things that you would like to see, either with enterprise tools or things that you're concerned with, or if you have obfuscated payloads, please send them my way. As always, happy hunting, fam, and I'll see you next time.